Actually, I wanted to take some time to talk about this problem, as I think it is a good practice on implementing recursion to solve problems, as a recursive solution requires a deep understanding of how recursion really works. So I'm assuming that you have already solved this problem using the iterative solution, or you have already thought about it and at least know the problem statement. So let's get started. The main idea here, or the main question, is to find the equation that calculates how this element, for example, this element moves or transposed to which cell. So if you thought enough about it, you will find that this element goes here like this, and that goes here, this goes here, and this goes here. And for example, also this goes here, this goes here, this goes here, this goes here. So if you think about it, you will find that every iteration is 4 cells, involves 4 cells, right? So 1, 2, 3, 4, 1, 2, 3, 4. And let's complete the final one. This, or let me just go with this here, this here, this here. So we completed one outer frame, right? One outer frame. So let's assume that it's a graph problem. So each graph is one of those directed 4 cells, like this, 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 this. So for example, let's take this graph, directed graph. We started from here, 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 here. So this outer frame involved 3 graphs, which is the one started here, and the one started here, and the one started here. So we only needed to process these 3 elements, which involved 3 graphs. Each one started from one of them. So we are going to implement a recursive solution such that when we go from this element, we carry the value of the current cell and the position of the desired placed cell, like 5 moves here. So we go with the recursive function here, carrying the 5, and this cell goes here in the recursion process, carrying 11, then here carrying 16, then here carrying 15. So when we come to the cell we started from, here is the base case of the recursion. So before we return, we replace the current cell with the current value that we carried from the recursive function. So this becomes 15, this becomes 16, this becomes 11, this becomes 5. And here, each time we call the recursive function, we process 4 cells. And for that also, we process this, and this, and this, and this. And the same goes with here. So if you thought enough about it, you will find that, or just try to ask yourself, how many cells should we process here to complete the whole graph? You will find that this one, this one, this one, and also this one. Could this take the whole 4, right? So in other words, we should only worry about these cells. So we are going to pass or call the recursive function 4 times on these cells. So the first question is we need a function to compute the desired cell that this element, for example, or this cell should move to, which is this one. So if you thought enough about it, you will find that the function is, let me just take this, f of x, or let it just be I and j, is going to be equal to j and n, which is the length of the matrix or the diagonal of the matrix. Like here, this is 4, this is 4, n, which is n is equal to 4, right? Minus I minus 1. So, for example, this element, this, which is I, which is 2, and j, which is 2, when we pass it to this function, we will get 2 and n, which is 4, minus I, which is 2, that's 2, minus 1, which is 1. So 2 and 1, we can find that this 2, 1, 6. So this is the function that we are going to use to implement the recursive solution. So we said that we need to call the recursive function 4 times. So the first thing, we are going to implement the recursive function, and the second thing, we are going to implement the loop that goes to these specific elements, for example. So let's try writing the code. First, we are going to implement the recursive function. Let's call it x. We said that it takes 3 parameters. First one is the location of the desired cell. So this 5, we pass it this location, the desired location, that it's going to carry the value with it, which is 5, right? So the next thing is the value, and we will pass a parameter called k. Now, what's k? K is the number that is going to indicate that we finished the recursive iteration, or what. Like we said that it's in every iteration we need to compute 3 cells, I mean 4 cells, like this 5, 11, 16, 15. So k is 0, 1, 2, 3, which is 4 iterations. So when k is equal to 0, which is the base case, if not k, which is 0, we replace the current cell with the current value and return. And if not, we keep the recursion going by implementing the function we said, which is f of I and j equals j and len matrix, which is n minus I minus 1. So we pass j len matrix minus I minus 1 and the matrix, which is the current value, matrix value of the current cell, and we decrease k by 1 to indicate the base case of the recursion. And after that, we replace the current matrix cell with the current value that we carried from the previous cell. So this is the recursive function. So the next thing, we needed to iterate through these elements, which is every cell involves 4, so that's 4 is equal to 16, which is the whole matrix. So let's assign 2 pointers, left and right, and an iterator called I, right? Left is equal 0, right equals to linear matrix minus 1, because we don't need to process the last element, we only need these 3 elements. And I, let's call it 0. I is the row we are processing. So here I is 0 and here I is 1, right? So while left is left and right, and for j in range L and right, left and right I mean, we involve the recursion function and we pass the value. So k is 3 by default, so we don't need to pass it, right? Now we need to increase I by 1. So this loop processes the whole outer frame. So we need to increase I by 1 to move to the next row, and we don't worry about infinite loop because left and right is going to increase left by 1 and right decrease it by 1. So if let me just let me take this. So left is here at the beginning and right is here. So when we decrease this by 1 and this by 1, this indicates that we moved to a smaller matrix, this one. So when it is increased, the left increased again and the right decreased, we know that we break the for loop. I suggest you try this in VS Code and trace the recursion to learn more about how the recursive function works. So let's run. Now, what did I do wrong here? J, then matrix, invalid syntax. Oh, don't know. What did I type that? List index out of range. So let me just try to. Actually, I don't know why I typed V here. It should be J. So I get this fine. Yeah, accepted. So that was the recursion solution, and I think it's a good example to practice recursion and know how it works. Like we carried the value from each cell, and when we went to the base case, we traced back, and when we traced back, we replaced the value of the recursion of the value we carried in the recursion process in the current cell. So I hope this is obvious, and thank you for watching.